Welcome to my YouTube channel MEP Tutorials. In this channel, we are learning HVAC, electrical, plumbing and firefighting courses on the different topics. Today I am come with a new topic called cold storage or the cold room design. In this topic, we will learn that how to design the cold storage, or in other words, I will say how to calculate the heat load calculation for the cold storage. Here we will learn with the many aspects how to design the cold storage tonnage or the required tonnage for the cold storage. So let's start the cold storage or the cold room design or the heat load calculation for the cold storage. Topic description step by step is what is cold storage exactly. We will learn what cold storage is exactly. Then we will learn who requires the cold storage and how to calculate the heat load for cold storage. So in these three steps we will learn about the cold storage. What is cold storage exactly? A cold storage is a room or space where a perishable products we can keep and preserve it for a certain time limit to use it again when it's required by keeping that products in a freezing point or lower degree temperature. A perishable products which has expiry date or a product need to consume within a time limit, such as foods, meat, chicken, milk and milk products, as well as vegetables and fruits, etc. These all are perishable products and it need to keep it cold storage in lower degree temperature. Who requires the cold storage? A cold storage always required by the farmers, perishable food distributors and the vendors, etc. to keep their perishable products overnight or certain periods precisely. If seasonal fruits came with a very good quantity, then it's required to keep it for a 6 or 8 months to cater the demand throughout the years. Seasonal fruits, very quick perishable foods, milk and milk products requires the cold storage or the cold room. So let us calculate the heat load for cold storage. To calculate the heat load for cold storage, below mentioned loads we require to consider. The first is transmission load. I will explain you about the transmission load. Transmission load is also called as a solar heat gain. The heat which is received by the sun from when the day start at 10 o'clock, then up to 4 o'clock or 4:30, the solar heat is always received by any place or any area. So if I am designing the cold storage, I must require to calculate the solar heat gain, and this is also called as a transmission load. Transmission load has a U value. It means outside temperature, when the outside temperature is transferring into the inside temperature of the cold storage and affect the product. So I need to calculate the transmission load for the same. Product load. Second is the product load. Product load is also important because a product which we are going to keep inside the cold storage, it affect the heat load of the cold storage. It means if a certain temperature has already obtained of any product and we are keeping that product inside the cold storage, our heat load will definitely affect. So we need to calculate the product load also. Then occupancy load. A product is carried by a people or the person inside the cold storage. So when the person is coming from outside to inside the cold storage, it is also carried some heat. So it is also required to calculate the occupancy load for the same. Lighting load. Lighting load, it is also called as electrical load inside in the cold storage. When we are calculating the electrical load, there is the wattage we need to consider. The wattage is expressed by the lightings, bulkheads, etc. So here we need to calculate the lighting load also. The fifth one is equipment load. Equipment load, what equipment is having inside the cold storage? There is the evaporator is having inside the cold storage. Evaporators is also called as a AHU or the fan with the coil, so we can call as a FCU also. So this FCU or evaporator is available in the cold storage and it is with the fan. So fan has the motor and motor express the heat. So we require to calculate the equipment load also. And the last is the infiltration load. Infiltration load is nothing but carried by the air with some temperature from outside to inside in the cold storage. Whenever we open the door of the cold storage, some air is coming inside and it affects our cooling load. So infiltration load is also important to calculate in the heat load of cold storage. So these are the main 6 loads we need to calculate at the time of calculating the heat load of cold storage. So let's start the calculation of the heat load for the cold storage. First of all, transmission load. Let us take an example. I have a one cold storage of this figure. The dimension of our warehouse type cold storage is 8 meter long, 6 meter wide and 4 meter high. So we can see that here is 8 meter long, 8000 mm, that is 8 meter long, 6000 mm, that is 6 meter wide, whereas 4000 mm, that is 4 meter high. So this rectangle or the cubicle type cold storage we need to calculate in the heat load. Now these cold storage having the 4 panel. Panel number 1, panel number 2, 3 and 4. So we need to calculate the surface area and as well as the U value of each and every panel. So how to calculate? We will see later on, but here I will calculate the ambient. Let us take an example. The ambient air is 40 degrees Celsius of outside the cold storage. It means the surrounding temperature of the cold storage is around 40 degrees Celsius at 50% relative humidity. The internal air is 10 degrees Celsius. It means inside the cold storage we required 10 degrees Celsius to keep a certain product at 95% relative humidity. The next condition is the walls, roof and floor are insulated with 60 mm polyurethane with a U value of 0.28 watts per square meter and the ground temperature is 20 degrees Celsius. It means outside the cold storage there is the 40 degrees Celsius temperature which is called ambient temperature. The internal temperature that is inside the cold storage is 10 degrees Celsius at 95% relative humidity, and the next condition is wall, roof, floor, all the area is insulated with 60 mm polyurethane. Polyurethane is the insulation using in the cold storage, so it has a certain U value. We will check which thickness has which U value in the next page. So here the standard panel we will consider here as a polyurethane with the below mentioned thickness and transmission values. So polyurethane insulation panel thickness in mm. These are the various thickness available with a transmission value or the U value in watt per square meter. So 50 mm has 0.33 watt per square meter transmission value or the U value, whereas 60 mm has 0.28 watts per square meter, 80 mm has 0.22 watts per square meter, and last one is 100 mm 0.18 watts per square meter. Let me explain you. These watts may be differs as per the product or as per the types of insulation. Here I am taking the polyurethane insulation, so the standard transmission value of the polyurethane insulation is like this. So to calculate the transmission load we will using the formula like this: Q is equal to A into U into in the bracket temperature out minus temperature in into 24 divided by 1000. Here the Q is load in kilowatts per hour. A is area of insulated wall or the roof panel in square meter. U is U value, that is also called transmission value of insulated panel in watts per square meter. Temperature out, maximum temperature at outside of the cold storage in degree Celsius, and the temperature end is required minimum temperature inside the cold storage for a certain product in a degree Celsius. 24, here we will take the 24, that is the hours in a day, because we are calculating our heat load for the per day purpose. So here I am taking into 24, and the last one is 1000. The 1000 is what 1000 is conversion from watts to kilowatts. 1 kilowatts is equal to 1000 watts. So here my calculation is a kilowatts, so I will divide this by the 1000. Let's calculate the area first for all panels. Panel 1, which we have seen, the panel 1 8 meter by 4 meter, that is 32 square meter. Panel 2 will be the same because that is the opposite panel. So here the panel 2 is also 32 square meter. Panel 3 is 6 by 4, that is 24 square meter. And panel 4 is also same, that is the opposite panel. 3 and 4 is the opposite panel, so the area of square meter will be the same. So all these 4 panels, and here is the roof. Roof is 8 meter by 6 meter, that is 48 square meter. So total area is 32, panel number 1, panel number 2 is 32, panel number 3 24, and panel number 4, that is 24. So total is 112 square meter. For panel 1 to 4, and the floor will be considered as a 60 mm thickness for insulated panel. So 60 mm is what? 60 mm is 0.28 watts per square meter. Then Q is equal to A into U into temperature out minus temperature in into 24 divided by 100,000. So we will take this equation to calculate the transmission load. So with all 4 panel, the area is 112 into 0.28 watt per square meter into 40 degrees Celsius, that is the outside temperature of the cold storage, minus the required temperature, which is inside temperature of the cold storage, that is 10 degrees Celsius into 24 divided by 1000. For the roof, Q is equal to 48 square meter into 0.28 watts per square meter into 40 degrees Celsius minus 10 degrees Celsius into 24 divided by 1000. So answer is 9.68 kilowatt per hour. For ground, same area as per the roof, 48 square meter into 28 watt per square meter, 0.28 watt per square meter into 20 degree, because here we are considered 20 degrees Celsius for the ground. So 20 degrees Celsius minus inside temperature 10 degrees Celsius into 24 divided by 1000. So answer is 3.22 kilowatt per hour. So the total is 22.58. This is the entire panel area, whereas 9.68, this is the roof area, and 3.22, this is the ground area. So these are the kilowatt load as per the area. So the total is 35.50 kilowatt per hour. So the transmission load is 35.50 kilowatt per hour. So I will give this as a A. Now the next is product load. How to calculate the product load? Let me explain you. Product load relates with the product exchange on everyday basis in a cold storage. It makes every new product comes with the additional heat gain. Thus, it automatically affecting the cold storage heat load. For example, a new lot of apples of 1000 kg arrives in a cold storage to keep it at a 10 degree Celsius temperature. Now here we require to know the standard specific heat of apples. We need to refer the chart from the below mentioned link. Each and every product has a different specific heat. So for that we require to refer the chart. And the chart is, the link for the chart is I have mentioned here. We can find the chart by this link. So a unit of specific heat of product is kilojoule per kg degree Celsius, that is kilojoule per kg degree Celsius. Example given, a specific heat of apple. Here I am taking the apple example, so that's why the apple specific heat is 3.64. as I am referred the chart, the mention in the below link, 3.64 kilojoule per kg degree Celsius, and the temperature when outside is 30 degrees Celsius. So if want to find the product load, then the equation is Q is equal to Cp. Cp is the specific heat into M into temperature inter minus temperature store divided by 3600. Here Q is the product load in a kilowatt per hour, whereas Cp is specific heat of product in a kilojoule per kg degree Celsius. M is the mass of product in a kg. The temperature store, that is the temperature required for apple to be kept inside the degree Celsius, whereas temperature enters the temperature of product apple when outside. So temperature enter is temperature of the product, that is the apple, when outside in a degree Celsius. Temperature store, the temperature required for apple to be kept inside the degree Celsius. 3600 is the kilojoule, that is 3600 kilojoule is equal to 1 kilowatt. Because we required a kilowatt, so we will convert the kilojoule into a kilowatt. So 1 kilowatt is equal to 3600 kilojoule is there. So the equation is Q is equal to Cp into M into temperature inter minus temperature store divided by 3600. Q is equal to 3.64, that is a specific heat of the apple, into 1000 kg, that is the weight of that apple, or that is the mass of the apple, into 330 degrees Celsius minus 10 degrees Celsius divided by 3600. We require to divide the 3600 because we need to convert it the kilojoule into the kilowatt. So product load is Q is equal to 20.22 kilowatt per hour. By this calculation, I will give this as a B. Now occupancy load. Next we will calculate the internal load from people working in the cold room or the cold storage, as people generate the heat and we need to account for this. We will estimate 3 people working in the cold storage for 4 hours a day, and we can look up and see at this temperature, then we will give off around 270 watts of the heat per hour inside. Each person express 270 watts of the heat. So we will use this formula. Q is equal to people into time into heat divided by 1000. Here we will take the number of people and the time spent in the cold storage, and the heat is expressed by the people. Q is kilowatt per hour. People, how many people inside is there? Time, length of the time they spend inside each day per person in hours. And heat loss per person per hours into a watt. So, and the 1000 just convert the watts into kilowatt. The calculation is Q is equal to people into time into heat divided by 1000. So if the people is 3 and the time is 4 hours and the watts expressed by the people is 270 divided by 1000, so my answer is occupancy load is equal to Q into 3.24 kilowatts per hour I will indicate as a C. The next one is lighting load. Let's come to the lighting load. Here the lighting load is calculate the heat generated by the lamp in the cold storage. For that we can use the formula mentioned below. Q is equal to number of lamps or the number of light into time into wattage divided by 1000. Q is kilowatt per hour. Lamps, the number of lamps or the light installed in a cold storage. Time, hours of uses per day. For example, lights on inside the cold storage for a certain time limit. So how many times the light is on or how many hours the light is on, we need to calculate that. And the wattage, power rating of the lamp in a watts. 1000 just to convert the watts into kilowatt. If we have the 8 lamps at 100 of the 100 watts each running for the 4 hours a day, the calculation will be Q is equal to number of lamps into time into wattage divided by 1000. So the number of lamps is 8 numbers into 4 hours into 100 watts divided by 1000. So the lighting load is Q is equal to 3.2 kilowatt per hour. I will indicate it as a D. The next one is equipment load. Here we will take the equipment load. Here we will calculate the heat generation of the fan motor in the evaporator. Now in a cold storage, there is the only equipment available is called as a cold storage, is a evaporator. Evaporator is nothing but the consist of fan and motor. The motor derives the fan, so we need to calculate the heat generated by the motor. So Q is equal to fans, or I will say the motor, into time into wattage divided by 1000. Q here, Q is equal to kilowatt per hour. Fan, the number of fan, or I will say the number of motor. Whenever I mention the fans, it is also come with the motor. Time, the fan daily runs per hour. And the wattage, the rated power of the fan motor, that is the watts. 1000 to convert from watts to kilowatts. In the cold storage, evaporator will be using 2 fan rated at 200 watts each, and the estimate that they will running for 14 hours per day. So calculation is Q is equal to number of fans or the number of motor into time into wattage divided by 1000. So here I will take the 2 fan, that is the 2 motor, which is running 14 hours into 400 watts divided by 1000. In this cold room, the evaporator, we will be using 2 fan rated at 400 watts each, and estimate that they will be running for 14 hours per day. So the calculation is Q is equal to number of fans or the number of motor into time into wattage divided by 1000. Q is equal to 2 fans into 14 hours into 400 watts divided by 1000. So my Q is, equipment load is 11.2 kilowatt per hour. I will indicate as the E. The next one is, and the last one is, infiltration load. Now we need to calculate the heat load from the air infiltration. Infiltration happens from outside to inside the cold storage. I am going to use a simplified equation, but depending on how critical your calculation is, then you may need to use other more comprehensive formulas to achieve the greater precision. We will use the formula as below. Q is equal to changes, that is the air changes per hour into the cold storage into volume. This is the volume of cold storage into energy. the energy expressed by the cold storage into temperature out minus temperature in divided by 3600. Q is equal to kilowatt per hour. Changes, the number of volume changes per day. The volume of the cold storage. Then energy per cubic meter per degree Celsius. That is the Apple energy of that particular cold storage. The temperature out is in the temperature outside and the temperature inside. The temperature is in the temperature inside. 3600 is the just conversion from kilojoule to kilowatt per hour. We will estimate that there will be a 5 volume of air changes per day due to the door being open. The volume is calculated at 192 cubic meter, that is 8 meter length of the cold storage, 6 meter width and 4 meter height. So the volume is 192 cubic meter. Each cubic meter of new air provides, that is 2 kilojoule per degree Celsius. The air outside is 30 degrees Celsius and the air inside is 10 degrees Celsius of the apple. So Q is equal to changes into volume into energy into temperature out minus temperature in divided by 3600. Q is equal to 5, that is the air changes volume, that is 5 into 192 cubic meter, that is the volume of cold storage, into 2 kg per cube 2 kilojoule per degree Celsius into 30 degrees Celsius minus 10 degrees Celsius divided by 3600. So infiltration load is Q is equal to 10.66 kilowatt per hour. I will indicate as a F. So the total load is, to calculate the total cooling load, we will just sum all the value calculated. Transmission load, what we have calculated is 35.5 kilowatt per hour, that is A. Product load we have calculated 20.22 kilowatt per hour, that is B. Occupancy load we have calculated 3.24, that is kilowatt per hour, I have indicated as a C. Then lighting load we have calculated 3.2 kilowatt per hour, that is D. Equipment load is 11.2 kilowatt per hour, we have indicated as a E. And the last one is infiltration load, we have calculated as a 10.66 kilowatt per hour, and that is F. So the total is A plus B plus C plus D plus E plus F, and the total is 84 kilowatt per hour. And the total load required for the cold storage is 24 tonnage, because 1 TR is equal to 3 kilowatt. So 84 divided by 3.5 kilowatt, that is 24 tonnage. So here we have calculated the total cooling load or the total heat load for the cold storage. So we required 24 ton evaporator and the outdoor unit for the cold storage. This is the way to calculate the cooling load or the heat load calculation for the cold storage. If you like my video, please subscribe my channel and push the bell button icon to get the notification. The end. Thank you.